that ball projected from level grounds and it's hit up at angle beta to the ground. So that's beta. And as we suggested earlier, that's the adjacent, isn't it? So phi cos B, phi sine B. And now you run through your four equations. Okay. We know that it's not affected in the x direction, so phi x is phi cos B. Phi y, phi sine B minus gt, yeah. We're using the formula phi equals u plus at to do that. Nothing else in the tables regards this. And then we're now going to use s equals ut plus a half at squared. So it's going to be phi cos B times t, isn't it? So phi t cos B. Next one. Phi t sine B, yeah, but there is an acceleration, so a half gt squared, yeah, or minus a half gt squared, because g is actually decelerating you, not accelerating you. Yes, sir. So it's asked to prove that. Now you guys need to do your dimensional analysis. What do you expect the units to be of this? No, but it's t, it's time. Yeah, so sub it in. Okay. The only two things that have units is velocity and gravity. So what's the units of velocity? ms minus 1, yeah. And the other one, gravity, which is acceleration. Now, they cancel, don't they? Now, what's the rules of indices again? The rules of indices state that if I gave you x7 divided by x3, what do you all tell me the answer is? x4, wouldn't you? You take them away from each other, yeah? So what's minus 1 minus minus 2? Oh dear. S minus 1 minus minus 2. Because it's already minus 2. It's just 1, isn't it? And that's your answer, isn't it? Just seconds. Okay. You have to find the range now, and you're using your four equations to do that, aren't you? And we all know that range is what? What distance is range? It's the sx direction at the time of flight. And we already have the time of flight, don't we? 2v sine b over g. Okay, come on. I'll put down your top here. 2v sine b all over g. Okay. We're looking to prove that the range is this much, but you know how to attempt it, right? As in, you're looking for an sx value at the time of flight. So you get the sx equation, all right? So ever see the sx equation? Phi t cos b. And you just change it to v cos b multiplied by the time of flight. Times the time of flight, which is, what's the time of flight? 2v sine b over g. Now you multiply this out, and is everybody agreeing that the range is currently 2v squared sine b cos b all over g? Anybody get that far? Cool. Now, here's what I want you to highlight. Are you looking? Look what I'm going to highlight here. I'm going to highlight the tail. A different color. I'm going to highlight the tail. I'm going to highlight the sine. I'm going to highlight the cos. And what you know is directly above it. So what can I change 2 sine b cos b into? Sine 2b, exactly. So it's b squared sine 2b all over g. Is that right? Cool. Now, deduce that the maximum range is u squared over g, and conducted the dimensional analysis on this formula. Okay, I want you all to take out your calculator really quickly. Right, I'm just going to do a quick little spot check on sine. You ready? Okay. What's sine 30? What's sine 60? 0.866, yeah. What's sine 88? 0.99. What's sine 90? What's sine 100? Ah, so when is sine at its maximum value? 90. So therefore, this function sine has a maximum value of b equals 45. Everybody know how I got b equals 45? Because 2 times 45 is 90. So 2b equals 90, b equals 45. And what happens if that is sine 90? What happens if I throw that as sine 90? What happens then? Sine 90 is, and that means your maximum range is phi squared over g. Okay, question coming in. Yeah. Dimensional analysis, guys. Okay, so what is the dimensional analysis? All right. So, dimensional analysis of, so just do phi squared over g. Is that right? So what's phi squared again? It's ms minus 1 squared. And the bottom? And what did I tell you earlier about the squared? Works on both of them, so you get m squared s minus 2 all over ms minus 2. And what happens then? M squared over m, which is just m. And range is measured in meters. How far I can throw a javelin is measured in meters. Do you get what I'm saying? How far projectiles travel is measured in meters. Now, next one. What's the maximum range of a golf ball hit from level ground with initial speed 35? I think we can get this answer quite quickly, can't we? What do you think? 35 squared over, anybody? 35 squared over 9.8. And what is 35 squared over 9.8? Huh? 125? Grand. Okay. Now, what would be the maximum range on the moon where the acceleration due to gravity is a sixth gravity? Okay, have an idea. We get our formula. Everybody see the formula we had earlier? P squared over G. Everybody see it? And what we do is we put a sixth gravity instead of gravity. What's 1 divided by a sixth? Anybody know? How many times can I fit a sixth into 1? 6 times, isn't it? So I can just get rid of the 6 in the bottom and put 6 here. It's 6 times bigger. So what can I do with that last answer? Make it 6 times bigger. What you get? 750 meters, yeah? Okay. So done 21 and that's do 13. In previous questions, we've already done the following. We've already proved that the greatest height is u squared sine squared alpha over 2g, provided it's tossed with an angle alpha at a speed u. We've also proved that the range is 2u sine alpha cos alpha all over g. You happy with that? Now what does this question say? What does it say? H equals, you all right with H equals R? So what do I need to write down? Yeah. Okay. Now, here's what I want you to do. Is everybody aware in the class of this formula that tan alpha is exactly the same as anybody? You don't know this one yet. Tan alpha is exactly the same as cos alpha, sine alpha over cos alpha. It's on page 13 of your tables. So you guys are going to use that formula. You're going to become very familiar with that formula very soon. Okay? So off you go. Okay. Ever see the sine squared alpha? See that? That sine squared alpha basically means sine alpha, sine alpha. And cancel that with that. Cancel the, oh sorry, my formula was wrong. That's 2u squared. My bad. The u squared cancel. Okay, sorry. So the u squareds will cancel. And the g's will cancel. And what I'll get is, everybody see the 2 and the other 2? Everybody see that 2 and that 2? Bring the bottom 2 towards the top 2, and what do you get? 4. And everybody see the cos alpha? See that sine alpha and that cos alpha? I'm going to bring the cos alpha directly underneath the sine alpha. Exactly. And tan alpha over 4. Tan means opposite over adjacent. So I'm actually doing a throw of 4 meters for every 1 meter. So it's quite a high throw. And then there's tan inverse 4 for the answer. What do you get? 75.96. That kill you guys? Okay. 75.96. Okay, it says I'm recording. So, yeah. So, next question. The maximum height projectile is double the range. Find the angle of projection. You're talking about it being twice the height compared to the range. That's going to be a pretty high. It's going to be a pretty high throw, isn't it? For not much distance. If any of us are golf players, think of using a pitching wedge instead of a driver. A driver would look something like this, where the range is many times the height. But in this case, the height is many times the range. So you're talking about a pitching wedge, and you're talking about a very steep angle. Everybody got that? If you're talking in golf terms. So what are we going to say for this question? 2h equals, or then what we're going to say? 2 times this formula, 2u squared sine alpha times another sine alpha all over 2g equals the range formula, 2u squared sine alpha cos alpha all over g. Now what's going to happen, guys? 2u squared cancels with another. G cancels with. Sine alpha cancels with. Bring the 2 upwards. Is that right? Huh? Tan alpha equals 2, is it? Yeah. Tan alpha. Wait, something's fishy. What's wrong with it? Everybody have it, tan alpha equals 2? Okay. Yeah. I thought it'd be steeper than the last one. Maybe we made a mistake in the last one. And tan inverse that, what do we get? 63 points.